Welcome to mathsmaster.org. We're going to have a look now at equivalent fractions. First of all, what are equivalent fractions? Okay, let's have a look at these three squares, of which all three of them have the same proportion shaded in green. So the same proportion of these squares is shaded in green. Now, first up, you might be able to say quite easily that clearly that square on the left has half of it shaded in green. So we look at that fraction, 1/2 is 1 over 2. Why do we have 1 over 2? Well, the 2 in the denominator, the bottom number, the denominator, 2 tells us that we could split that square up into two pieces. And if we did, one of them, which is the numerator, the top of the fraction, one of them is shaded in green. Right, okay, so we could describe the proportion of that square that was shaded in green as 1/2. But couldn't we also describe it as 2/4? Have a look at that second square, the one in the middle. The same proportion of the square is shaded in green, but this time I've split the square up into 4 equal sized pieces. So there's a 4 in the denominator, the bottom of the fraction, and there's 2 of those pieces shaded in. So the numerator, the top number, is 2. So we can describe the same proportion of the square as being shaded in with 2 different fractions. Or maybe actually 3 different fractions. Have a look at the third square now. Now I've split that square up into 16 little equally sized pieces, little squares, and you'll see that I've now shaded in 8 of them. So we could also describe the proportion of that square that's shaded in as 8/16. Okay, so another way of thinking of fractions is as division sums. The top number divided by the bottom number, the numerator divided by the denominator. So 1/2 is exactly the same thing as 1 divided by 2, which if you type it into a calculator or you use short division, you'll see is 0.5. But if we look at 2/4 or 2/4, if we do 2 divided by 4, you'll notice that we also get 0.5. And indeed, if we do 8 divided by 16, we also get 0.5. So you'll see that if we look at fractions as being division sums, 1/2, 2/4 and 8/16 all give us the same answer, 0.5. So 1/2, 2/4 and 8/16 are what we call equivalent fractions. And what I mean by that is they look different, they've got different numbers in them, but actually they are the same size. What I mean by that is if you think of them as the proportion of the square that's shaded in, it was the same for all those fractions. Or if you think of them as division sums, we got the same answer when we did numerator divided by denominator on all of them. So they look different, but they're actually the same size. And this is what we mean when we talk about equivalent fractions. Right, okay, let's have a look at how we actually go about finding equivalent fractions. So if I said to you, find an equivalent fraction to 3/4, let's have a look at how we go about doing that. Right, here's a square. A proportion of it is shaded in orange. 3/4 is shaded in orange. As you can see, I've split it into 4 equally sized pieces. 3 of them are shaded in, so 3/4 of that square is shaded in orange. Right, an equivalent fraction we could find by taking the same proportion of the square in the second one, the same proportion is shaded in orange, but now I divide it into 8 equally sized pieces, as you can see. So 8 would be in the denominator of my fraction at the bottom, and now 6 of them are shaded in orange. So the equivalent fraction would be 6/8. So let's have a look at what we actually did there. I started off with 4 equally sized pieces in that first square on the left. And then I said, on the square on the right, I've now got 8 equally sized pieces. I've doubled it. I've got twice as many pieces in the second square as I did in the first square. And consequently, twice as many of them are shaded in. So you'll notice if I times the bottom number by 2, I've also times the top number of the fraction by 2. 3 times 2 is 6, and the bottom number, 4 times 2, is 8. Let's have a look at what we've done there. Let's take that in. We've taken the top number and we've doubled it to make 6, so twice as many pieces are shaded in. But the bottom number, 4 times 2 is 8, we've doubled the number of pieces that we started with. So that's how we find an equivalent fraction. Let's have another look. 3/4 is also has an equivalent fraction of 9/12, as you can see in this diagram here. You'll notice in the second square now, I've split it into 12 equal pieces, and 9 of them are shaded in. So these two are equivalent fractions. From going from the first square to the second, I've used 3 times as many pieces. I've gone from 4 equally sized pieces on the first square to 12 on the second square. So I've times it by 3. I've got 3 times as many pieces. But then look, 3 times as many of them are actually shaded in on the second square. So we've gone from 3 shaded in to 9 shaded in. So that's why these two are equivalent fractions. If we times the top number by 3 to go from 3 to 9, we also have to times the bottom number by 3 and go from 4 to 12. Okay, so to summarize now, let's have a look at how we find these equivalent fractions. If I said to you, 2/5, can you find me an equivalent fraction? Or find some equivalent fractions. Here's how you go about it. Think of a number, say 2, it can be any whole number, say 2, and then times the top and the bottom numbers by 2. So 2 times 2 is 4, and 5 times 2 is 10. So 2/5 and 4/10 are equivalent fractions. But maybe you didn't want to times by 2, maybe you wanted to times by 5. Well, that's fine, as long as you're timesing the numerator and the denominator, the top and the bottom, by the same number, in this case 5, you'll get equivalent fractions. So 2 times 5 is 10, 5 times 5 is 25, 2/5 and 10/25 are equivalent fractions. You might like to times numerator and denominator by 9, as you can see here. You might even like to times them by 200. It doesn't matter which number you times them by, so long as you times the top and the bottom by the same number. The numerator and the denominator need to be times by the same number. That way you'll get equivalent fractions. Okay, just to finish off, I want you to have a look at this now, where I'm actually using divide by 10 to find equivalent fractions. So up to now we've been timesing the numerator and the denominator by the same number. It also works if you divide. You can't add and subtract, it doesn't work if you use those, but if you times or divide by the same number in the numerator and denominator, that's okay. So 30 divided by 10 is 3, and 50 divided by 10 is 5. So 30/50 is the same, is an equivalent fraction to 3/5. Another example would be if I wanted to divide by 2. Once again, it doesn't matter what number you divide by, so long as it's the same in the numerator and denominator. So 30 divided by 2 is 15, 50 divided by 2 is 25. One thing you do need to bear in mind when you are using division to find equivalent fractions is obviously you need to choose a number to divide by that's a factor of both the numerator and the denominator in that first fraction. So with 30/50ths, I couldn't divide by, say, 17 because it's not a factor of 30 and it's not a factor of 50. If I did that, I get decimal numbers, and we don't like decimal numbers in fractions. So just bear that in mind if you are going to use division to find equivalent fractions. Okay, so to summarise, equivalent fractions, what are they? Well, we've seen that they're fractions that look different, but they're actually the same size. They're describing the same size. Okay. How do we find them? Well, we multiply or we divide the numerator and the denominator of the fraction by the same number. And that can be any whole number. That was how to find equivalent fractions. If you want to see some more fantastic videos, please visit mathsmaster.org.